I want to move into some examples, if I can. Here again, we're going back to that table I showed you, the staff branch table. I know you're really tired of seeing the same thing again and again and again. So here is just breaking down that entity and doing some analysis. So the primary key is the staff number. The attributes of the table staff branch is S number, position, salary, branch number, and the branch address. So how do you determine the transitive dependencies and functional dependencies? You've got to look at each attribute. You've got to look at the primary key. Let's say staff number is the primary key. So with the staff number, I can find the staff name or S name. And then you have to think, from S name, what can I determine? From the name of the staff, what can I determine? Really, if you just know a name of a staff, you can't determine much, because you could have two staff with the same name. Does this make sense? It can be that you've got two staff with the same name. So knowing the name, it doesn't determine anything in reality. Okay. Then knowing a position. So for example, if you know somebody is a admin staff, and you could have 200 admin staff as your staff members. So if I say my position is admin staff, tell me my name, tell me my branch address or branch number, you can't really tell me, because there are 170 or 200 staff that are admin staff in this case, in this example. If I tell you how much I'm earning, you won't be able to tell me my name. So let's say next time you see me on the street, you ask me how much you earn, I tell you, and then I ask what's my name, you don't know. You can't go to this database and find my name from how much I'm earning, because there could be many people that are earning the same salary. If I tell you the branch number, you can find out all the staff that probably work in that branch. Yeah? Oh, sorry. Yes, you can, in a sense, because the branch number is unique. But if I tell you the branch number, not only you can find some information about the staff, but also you can find the branch address, because the branch address and the branch number are together determine the branch, in a sense, in this case. So here what we're saying is, from a staff number you can find the branch number, and then from branch number I can find the branch address. Does this make sense? But from a staff number, I'll just find the staff name. From a staff name, I cannot find anything else. Does this make sense? Hopefully it does. So another thing that I want to talk about in your book, and many of you, and over a few years that I did teach this subject, or I'm teaching this subject, got in touch with me about this. This is a diagram in your book, and everybody sort of get confused with it. There's nothing to confused about. It's just a notation that these authors decided to use, and you probably don't see it in any other book. I've seen it in other books like this. There's some similarities to some other approaches in other books, but this is just unique to this book. So what we're saying here is this diagram. What is this diagram saying? All right, this diagram saying that A, B, C, and D, and E are the attributes of a table. All right, the table is called sample relation. This is a sample relation. This is the name of the entity, and the attributes are the column names A, B, C, D, and E. And everything that you see below that are the values related to that table. So they are just a set of data for the first row, second row, third row, fourth row, fifth row, and sixth row. That's what it is. No meaning. Right? Would have been better if you just they did the example with the staff table, something like that. Nothing specific. So it's a table. Imagine the name of the table is sample table, and the attributes are A, B, C, D, and E. And in this row of this table, there's some data that's stored. Okay? That's what it is, nothing else. And what we are saying here is A determines C, C determines A, because we draw these arrows. You see? This arrow is just saying that. And then what we're saying is here, B, column B, determines the value of column D, and column A and B determine the column E. That's all it is. Just representation. Nothing beyond that. So we're saying that in a table, for example, you could have multiple dependencies between different attributes. That's what we're telling you. Nothing else. Right? That's it. You can come and ask me a question about this, and I'll tell you exactly the same thing. So don't get confused. Don't try to make sense what is in the first row of this table. Letter A, letter B, Z, W, and Q stands for. I have no idea. It's just an example. Okay, but from that, you can write this. A determines C, C determines A, B determines D, A and B determine E. And that's what I told you. This arrow says A determines C, C determines A. You see the arrow? B here determines D, and A and B determine E. So if you want to do some representations for yourself in your tables, you can do this instead of using this notation. So an FD here, FD1, FD2, FD3, FD4, saying that there are 4 functional dependencies. This one, A determines C, we call it functional dependency number 1. C determines A, we call it functional dependency number 2, FD2, and so on and so forth. That's it. Going back to what we said, choosing the correct primary key is very essential. When you choose a primary key, please try to choose the minimum number of attributes if possible to build your primary key for each attribute. If you've got transitive dependencies, as we told you, if there is an attribute that's not a primary key in your table, and from that attribute, in that table, you can determine another attribute, that's a transitive dependencies. Remove transitive dependency by removing the attributes that are transitively dependent on each other to another table and creating new table that we talked about. Normalization has got different stages. So you've got the first normal form, second normal form, third normal form, fourth normal form, or B, C, and F. And at each stage, so when you try to check your design, you apply one rule at a time. So you say, okay, is this design in the first normal form based on the following rules? And I tell you what the rules are. You check it. Yes, you tick yes. You move to the next set of rules, apply it to your design, and say, okay, does it pass the second normal rule, second normal form rules? Yes. You now then apply the third normal form rules. So if it doesn't pass the first normal form rules, you have to fix it before you apply the second normal form rules. Then when you apply the second normal form rules, you have to fix your design so it passes all the rules and all the conditions, and then move to the third normal form. So what we're saying here is, as you go up in the normalization stage and you apply different set of rules that are at each stage, your design becomes better and better and better. Okay. So here it is, again, similar to what you've seen. You get the user requirement, you look at the reports, you get other interview your users, you build a scenario. From the scenario, you do a design. Then your design, you apply the normalization rules. First, second, and third normal form.